Hey guys, so we'll look into this Java collections today. Okay, we had seen data structures wherein we had enumeration, bit set, vector, dictionary, properties and all. But each of them was different from each other. There was nothing like a standard practice between all of those. Okay, so for that there is a new collections framework that was developed. Okay, later on. So this framework contains a specific set of kind of data structures only, like to store a lot of data of multiple types. Okay, so this contains mostly interfaces, like structure, a skeleton is given but not its definition. Okay, then the collection framework is implemented in subclasses like list, uh, set, map, enumeration and so on. So these are the subclasses under the collections framework. Okay, and these have the implementation of each of the um, parts like maps, list and everything. Okay, then we have linked list, array list, hash set, linked hash set, maps and so many of them. Okay, so once we have so many of these, we'll have to look into what the collection interface is, what the list interface is, and what the set, sorted set, and so on. Okay, so moving to collection interface, this is the base for everything, for all the types of collections like list, linked list, whatever they are. So in this base framework, we define some sort of array or a group kind of thing, and then we give it few methods to add new elements, to remove the old elements out of that one array, and you want to do some operations over them, calculations, comparisons, and you want to do a for loop kind of thing. So you have iterator. Okay, then we have this remove and something to convert into some other data type. So we all have these methods. So how are we going to work with these collections? Within collections, these are all defined, predefined. Array list, linked list, hash set, hash map, tree map, and many others. So in array list, what is it? Just an array, but it's more like dynamic size. In array, you have to define the size when you're making up a new array, but here you don't have to define a size. You just declare a new object of the type list, sorry, of the type array list. Array list are all under list again. Okay, array list, linked list, then we have sets, then we have maps and all. Okay, so within list we have multiple types. One is array list. So in array list we have this add method to push new elements into it. So once we push new elements into it, it just looks like a simple array list elements. Okay, then linked list as also looks like same, because we have inserted only the elements like this. Okay, then we have hash set, hash map. All of them work in a similar manner. Unlike what we have seen, dictionary, enumeration, everything work in a different way, but these all are going to work in the same way. Okay. Then the list, map, set being subclasses, there are few additional methods that are supported in each class. So this is the list interface. Inside list, they have few additional methods. Okay, so in addition, it already inherits collection, apart from the methods that are present in the collection, it has its additional methods. So these are the additional methods, mostly self-descriptive as per the description given here. Okay, so like you want to get the elements out of it, or you want to compare, or based on index you want to break the list into a small list, and you want to get unique items out of it, no repetitions, and so on. Okay, we have seen this, like how a list will look like, and within this list, A1, within A1 we can do A1 dot get, then A1 dot sublist, and many other operations. Okay, for the same A1, all these operations can be performed. A1 dot set, A1 dot remove, and stuff. Then these are the additional for a set. The difference between the list and set is that the set will allow only unique elements. It does not allow repetitions. Okay. Then these are the methods, the additional methods which are supported apart from the collections. Set does not support the list methods. Set will support the collections methods and these methods. Okay. Based on these methods, we have this set. This is how we define a set. It is a part of hash set is a part of set. Okay, so we are defining a hash set here, and so we are pushing elements into the set. Okay, once we push the elements into a set, we can do various operations like sorting them. For example, we have this tree set. Okay, tree set is something like it would take only in the ascending order. Okay, whatever set you give, you feed it to the tree set will automatically convert it into some sort of ascending order. Okay, and then similar to tree set, we have a sorted set. Okay, if you provide a set to a tree set, it is sorting it. But when you are pushing elements into the set, it is pushing in the same order which you have given. If you have declared the same set as a sorted set, yeah, sorted set, new tree set. So this takes inputs and puts it in the right position. It simply replaces. So we are pushing B, it will be the first element. Then we push C, because it is in ascending, this will be second element. When we are pushing A, this goes first and these two get pushed back. So this gets position 1, this gets position 2 and 3, because this is a sorted set. So sorted set would sort the elements if you are pushing something, and then if you are removing something, it would automatically adjust. There won't be any blank space. If you are removing A, B and C will move its position back to 1 and 2. So this is sorted set, which is a part and parcel of the set. Okay, tree set is one type of set, and inside tree set we have this sorted set. Okay, so in sorted set it is all sorted by from the beginning itself. Once we have this sorted set, then we will look into maps. Okay, so these are the methods which come additional, like comparator. First headset is like you give C, it will, if you ask for headset, it will say A and B, so something before the end. And tail set is like you give B, it will return C, so something after the start, whatever you are giving, after this whatever is there, that would be returned. And similar to list, sublist, we have subset, first element, last element, then You can compare the two sets like comparator. Then we have map. As the name suggests, map, you are mapping two things, keys and values. So map is more or less similar to dictionary. Okay. So in this map, if you want to get a key or get a value, replace everything or replace all the values with one single value, get its size and then values, all those operations we can do on maps. So for map, we don't do map dot add, we do map dot put. Okay, that's the only difference between the regular ones and here. And inside put we will have two arguments. The first one will be key, the second one will be value. Okay, and so it looks finally like this, like a dictionary how we discussed. Some value equal to, some key is equal to some value. Okay, so after having maps, um, we have already looked into enumeration, which is one type. Then we have this map entry. So every pair, key value pair is called an entry in a map. So if you want to work with each of the entries or all the entries together, you want to get a list of keys, okay, or you want to get a list of values. So we work with map entries. We have like get key, get value, okay. Then we have set value, reverse. You give the key and for that key you will be setting an object. It doesn't have to be a number every time, it can be any object. Okay, so in a map, this is a map. This is how we have declared map earlier and then we did put. Once we did put, now we will declare hm dot entry set. So entry set is some method which will read all the entries present inside a map, like all the key value pairs. It will read all those values. We have discussed iterator. Iterator is more or less for loop. It iterates through each and every element present inside the map or any collection in fact. So most of the collections will have the iterations. Okay, once we get the iterator, if there is any next element, so I equal to set dot iterator. So it is iterating among this set values, sorry, set elements. So in that set elements get the next value. So this is the method to get the next element. This is to verify if it has next element, but it will not navigate to the next element. Okay, so that will get the key value pair. Then you will do a get key to get the key out of it individually. Then a get value to get the value out of it. Okay, and then you can do any operations on it, like adding, subtraction, any operations you can. Okay, so these are the collections that we are having. And then apart from collections, you want to run multiple programs at the same time. For example, uh, I have a test case. Okay, I want to run that test case on all the browsers that I have. Internet Explorer, Mozilla Firefox, and Chrome, Opera, Safari, whatever browsers I have. I want to run all of them together. So my machine will support things to run in parallel, applications to run in parallel. Okay, when I'm running applications in parallel, I want to do actions in parallel for all the same things. So I use one concept in Java, not in Java, in the operating system called threads. So thread is like one road, you take it, One, you follow it, you finish it. Okay, so you create multiple threads like that to do the multiple processes at the same time. So multitasking at the same time, right? So once you have each of the thread active, so each of the thread will start running. Okay, so you start a new thread. If it is running, well and good. If it has a wait cycle, okay, it will wait. For example, Internet Explorer, my application will load slow. In Mozilla, it is very fast. So I have written my Selenium code in such a way that if I am opening Internet Explorer, okay, it will take some sleep. So waiting time, sleep or wait, whatever you call the waiting time, it will take. Okay, and this with the Chrome and Firefox, it keeps on going very fast. Once it starts running in the Chrome and Firefox, okay, it is finished. One thread is finished, so the thread will be closed. But IE keeps on running. It's not like one thread is killed, so the other thread has to die. Each thread is independent, and each of the working line are independent of each other's timelines. So here I am clicking on one link. There I might be still waiting for the link to open. Then here I am clicking on the second link. Now there I am clicking on the first link. So they will run in parallel, but not at the exact same operation has to happen. There is no rule. Okay. So it can do the waiting and all. So each thread is independent of each other. So this is the procedure to start a thread. We have this method called run, predefined method. So use with the help of run, we will run a thread. Okay. Mm, yeah. So we are having this run. Then here we are creating multiple threads. Okay, running thread name. So we are running 4 threads here and waiting for some time for the thread to wait. As I said, each thread is independent of the other, and one thread is running. In the middle, I have started another thread. Okay, that is also possible. So I have started thread 1. Sorry, I have created thread 1 and asked it to start. Then creating starting. And thread 1 is already working. And now you started creating thread 3, 4 and so on. You can create continuously and you can wait. Each thread is independent of each other. So basically you are doing some parallel tasking. Okay, so that is about multi-threading. So if you want to know more about threads, you can go to some operating system related concepts to understand more about threads, how threads happen. So we have this number of cores in CPU, like we have this i5, Intel i5, Intel i6, Intel i7, quad core, octa core processors. Even in our mobiles we have so many cores. So each core can support one process, and inside process there will be threads. Okay, so multiple threads can run inside each process. Okay, so so basically your processor, your CPU is going to be split and be used by each of the threads. Each thread is like one task. You give your computer one task to open Notepad and type. In the meanwhile, it is running Selenium in the background on its own. In the meanwhile, it has opened Outlook and it is continuously refreshing to see if you got any new mails. And you also keep chatting over some Skype or Messenger or something. So all of them are like continuous things. Yes, to handle all these continuous things, we have this multiprocessing. And Windows allow only one user to log in at a time, but any Unix machine you can log in with 2-3 users. Okay, I have 3 machines, like 3 small laptops. Then I have one Unix machine placed over there. Okay, from each of the machine, I'm trying to access one uh, with different user credentials. All the 3 will work. Okay, just that the monitor has to be different and the connection mechanism has to be different. So Unix is more powerful with respect to multi-threading. It can do multi-threading at the level of users. Windows can do multi-threading only at the level of applications. It cannot do multi-threading with respect to users. If you try to log in with multiple users in a similar way which you did for Unix, either the latest user will be active and the previous user will automatically log off. Okay. And so more about the multi-threading, you can look into the operating system concepts. Okay. So these are all the basic methods which we work on threads. And when writing programs, you might come across something called thread.sleep. That is the basic waiting mechanism used by any no voice coder. Okay, so thread.sleep. So whatever thread you have initiated using your public static void main, that thread will simply wait. It will not do anything. It will just wait. It's like your computer is dead. It's not doing anything. It's not even thinking. It's not even talking. It's not doing anything. It's just waiting on. It's not waiting on something. It is simply dead. Okay, so you would see that thread.sleep quite frequently. Okay, then you would call the current thread sometimes when you want to go over which thread you are working with. You're working with Chrome, Firefox and all. So you would call the you would give the thread a name and you would call the thread. So these are all the methods that work with the threads. Okay. Yeah. So um, I'll ping you each one question. Just take some 10-15 minutes time right now. Check it online. Check it through any resources. Like 15 minutes is also not a problem. Okay, I'll ping you in individual. Then you would be explaining those concepts back to me. Okay, whatever the question I gave you, you'll be explaining it back. Okay. Mm, yeah, Diksha. So what is the difference between data structures and collections?
Okay. Yeah.
Okay. And then Muzammal, what is the difference between array list and linked list? ARRAY array list and linked list. Okay, like this one, second one. And Umer, so you have this hash set versus tree set versus linked hash set. Okay, so the three of you have some time. Just let me know when you are ready. Okay. Muzammal and Umer, please acknowledge.
Yeah, I'll let you know when I'm ready to
I'm
answer the
working
question.
You're already ready?
working on. Okay.
I'll let you know.
Okay,
I'll take like 2-3 minutes.
right. Yeah,
Be
Umer.
back with you.
Okay. So a hash set is like an unordered and unsorted set. Linked hash set is the ordered version of hash set.
Okay,
The
so
only difference is that the linked hash set maintains the insertion order.
mm-hmm.
When we can iterate through a hash set, the order is unpredictable, sorry, while it's predictable in the case of linked hash set.
Okay, so tree set and linked hash set. When does tree set come into picture then?
She said versus linked hash set, you said?
Yeah, three things. As you saw
Oh,
on
okay.
my screen, hash set, tree set, linked hash set. Three things.
Well, tree set is a sorted set implementation which allows to keep elements
Okay,
in a
so
sorted order.
you said linked hash set is also sorted kind
Uh,
of, yeah.
let's
So
see, LinkedIn.
what difference does it have between tree set and linked hash set?
Okay, so hash set and linked hash set uses equal method in Java for comparison, but tree set uses compare to method for maintaining order. That's why compare to should be consistent to equals in Java.
Sorry, I didn't understand.
Linked hash set and linked set uses equals parentheses method in Java for comparison,
Mm-hmm.
but tree set uses compare to.
Okay. Okay. So both are the sorted type of sets, but linked hash set will maintain the order of insertion and it can be compared just with a simple equal to, but tree set
Yeah,
cannot be compared with simple equal to. It needs a comparator method, right?
exactly. Yeah,
Yeah. Cool. Nice one.
yeah, no problem.
Yeah. So let the others also come up with their answers. Okay. Yeah.
Okay, sounds good.
Oh, okay. Okay, like I was just reading about this, and it says like input stream is basically for the binary.
Mm-hmm.
Yeah, it reads the binary data, and whereas the reader actually reads the character data or the text data.
Yeah. Yep. Is that the only difference?
Hmm, I guess.
Okay. Yeah. Input stream can read only one byte at a time, like 8 bits. File reader can read 16 bits, like 2 bytes at a time.
Okay.
And that is why it can deal with bigger data and more text.
Oh, character is 2 bytes, so yeah, okay. Got it. So while programming, we can just use file reader for a safer purpose.
Sorry, I didn't get you.
So when we're using these, we can use file reader instead of file input stream to be on a safer side. I mean,
Yeah, yeah, it's faster.
yeah.
File
Okay.
reader is faster. And yeah, it doesn't break much data.
Okay. Yeah.
Hey, Muzammal.
Yeah.
Yeah, so yeah, so you could figure out the differences, or shall we?
Yeah. Array is dynamically stored, and then linked list, uses called doubly list method, which is like you have to have the information of the previous and the next list.
Right. Yeah, so the same thing, order of insertion.
Yeah.
Y- Yeah, okay. So that's all. So we'll connect tomorrow, and we'll do what? Yeah, we'll just practice, and we'll have some assignment for the weekend. Okay. And chalo, see you guys. See you guys tomorrow.
Bye bye.
Bye.